All right, in this lesson, we're going to continue working with one-step algebraic equations, and we're going to keep solving them. Last week, you solved them basically using guess and check, and some were easier than others. But today, we're going to use algebra, and we're going to use something called inverse operations to solve these. So let's go ahead and review the answers to the do now, so you can turn the next page. So the last week or so, we were translating expressions. And what this do now is about is translating equations. And the key word in these, and you're going to see different words that mean equal, like is, and is the same as, and equals, and is equivalent, and is, which translates to equal signs, which means we're translating these sentences into equations, not just expressions anymore. And we'll be doing some more of that later this week. So go ahead and turn to the next page and we'll check the homework answers real quick. Again, most of these equations you're able to figure out just by using a little common sense, figuring out what number plus 5 is equal to 13, what number plus 4 is equal to 15, 3 times what number is 24. So today we're going to learn how to do this algebraically. All right, so let's get to it. So there are a couple of concepts I want you to understand before we get into this. And the first one has to do with balance. So take a look at what we're doing here. I have a scale. I have the same thing on the left and the right, so this is balanced. But now I'm going to unbalance it by adding something to one side. And you can see there's something new here. And the question I have is, what do I need to do to make this balanced again? And I'm not going to take away anything. It's like, what can I add or what can I change to make this balanced again? And I think without too much difficulty, you can see that I need to add another circle on that side. And now that, again, will make both sides balanced. So I made a change to this side, but then I made a change to this side, and I now have balance. Now take a look at the right-hand side. Go ahead and pause the video for a second, and I want you to do the same thing here. I want you to draw in what it would take to make these two sides balanced again. So for this, as you can see, I added 2 blocks here and an extra block up, an extra circle up here. So to balance the other side, I had to add the 2 blocks here and the 1 circle here. Now both these sides are balanced. So the big conclusion here is, if I add something to one side of a balanced scale, I have to add the exact same thing to the other side to keep it balanced. This is really important concept. And you're going to see how it applies to equations on the next page. So go ahead and turn to that page. So here's the deal. Equations are like a balanced scale. Whatever you do to one side, you have to do to the other. And when we solve equations, we make changes to the equation. And we make changes in order to get the variable by itself. So let me show you an example here. So I'm going to change the left-hand side of this equation. I'm going to add a minus 5. All right, so now that I've changed the left-hand side, that means I have to change the right-hand side in the exact same way. So I need to also put on this side a minus 5. All right, so how does that help us? Well, you can see that 5 minus 5, of course, is going to be 0. So now I have x minus 0, but that's just the same as x. And that makes me happy because I want to get x by itself. On the other side, of course, I have 8 minus 5, and that's equal to 3. So I'm sure most of you saw that the answer to this one was x equal to 3 without doing this. But the problems are going to become more complicated, and being able to change the equation to get the variable by itself is going to be a little more tricky. So once again, solving equations is about making changes that keep the equation balanced and getting the variable by itself like we did here. All right, let's take a look at a couple more examples. So go ahead and turn to the next page, please. So the concept that we're using here is called inverse operations. And let's talk about what that means, first of all. An inverse operation, they are, another way to think about it is opposite. So please write that in. And let's talk about what those inverse operations actually are. So we know that subtraction, for example, is the inverse operation of addition. And division is the inverse operation of, and you can probably guess this, is multiplication. So how do we use these inverse operations? So they help us solve equations. So I want to write that in. They help us solve equations. By undoing operations. And of course, the goal is to get the variable by itself. All right, this will all make sense when we do an example or two. So let's take a look at this problem here. We have b plus 3 equals 7. Again, most of you are going to be able to look at this and figure out what b is supposed to be, but we're going to use algebra to figure this out. So the hint that I give here is use the inverse operation on both sides. So my operation is plus 3. The inverse operation of that is minus 3. But I'm changing this side, so I have to change this side in the exact same way. So this becomes minus 3. So I have 3 minus 3 is 0. And I have 7 minus 3 is 4. But of course, b plus 0 is just b equals 4. And again, you knew that that was going to be the answer. You won't have to write this step all the time. You can just bring this down to b equals 4. So go ahead to the next page and do a couple of these quick problems. So here are 4 problems I'd like you to apply the inverse operation to in order to get the variable by itself. So doing what we did on that last problem, pause the video, work on these, and then come back and check your answers. All right, let's check out these answers. This one I think was pretty straightforward. This one is a little bit different because the m came first, but the opposite operation is minus because we really have a invisible plus here, right? We assume that that's a plus 16. So we have to undo that, do the opposite with a negative 16, with a minus 16, in order to make that go away. So the plus 16, we have a minus 16 to make that 0, so we're just left with m. Here we have our first minus 3, so the opposite, the inverse operation is addition, so I have to do a plus 3 on both sides. That gives me n equals 10. Same thing over here. My operation is minus, so I have to do the inverse operation of addition, do it on both sides, and then I get my answer is 53. All right, let's look at some multiplication and some division problems on the next page. So let's talk about these for a second. So these are multiplication. Remember, that's when you have a number right beside the letter. These are like being multiplied. That's really important to remember that. So we said the inverse operation of multiplication was division. So that means we're going to do division like a fraction. I'm going to divide both sides by 10. Right? I have to keep it balanced. So 10 divided by 10 is 1. So that gives me 1 times m. That's a multiply, okay. Equals 90 divided by 10. We know that's 9. But what is 1 times m? Of course, 1 times any number is the number itself. So that's why we divide here, so that we get 1 to multiply by the number in order to get the number, get the letter all by itself. The other thing I want to bring your attention to, whenever you see the division sign that we see in number 7, I would change that, actually, and make that n over 4. I think that'll be easier to follow what you're doing with that one. All right, so you're going to apply the opposite operations, the inverse operations. Go ahead and pause the video and work on 6, 7, and 8, and then come back and check your answers. All right, check out these answers. Here we divided both sides by 2 and got x equals 18. Let's take a look at the division problems. So we're dividing by 4. The inverse operation is multiplication, so we're going to multiply both sides by 4. Another way to think about this, so the 4's are going to cancel out. So you really have 4 on top and a 4 on the bottom. That gives you the 1 like we had up here, and therefore the n ends up by itself. So think of these as canceling each other out when you have the same number on top and same number on the bottom. Of course, when I multiplied 4 over here, I have to multiply by 4 over here, and that's why I get 20. Same thing over here, I have to multiply by 5, so that these two 5s cancel out, the one on the top and the one on the bottom. I have to multiply the other side by 5, and I get 55 in the process. All right, go ahead and turn to the next page. I have a little bit of mixed practice for you. So go ahead and work on these problems and solve using inverse operations. And also do this problem in the box. This goes back to what we did on Friday. I want you to come up with the equation like we did, like you did for the homework as well. Figure out how many coins will be in the bag, but also solve your equation algebraically as well. All right, pause the video, work on these problems, then come back and check your answers. All right, check out these answers. For number 1, I had to do the opposite and subtract 7 from both sides, and I get 10 minus 7 is 3. For this one, I'm multiplying, so the inverse operation is division. So I divide by 4, the 4's cancel. On the right-hand side, I divide by 4, I get 5. This one's a little bit trickier because the variable's on the right-hand side, so this is the side that you're changing. You're changing the side that has the variable on it because you're trying to get that by itself. So my operation is a minus 3. I'm going to do the inverse and add 3. Of course, then I have to add 3 on this side, so I get g equals 18. Here's a division problem. So the inverse of division is multiplication, so I'm doing 3 times this. And then, of course, I have to do 3 times on the other side, so I get r equals 12. Then in the box, again, I have my left-hand side is 8. My right-hand side is the bag of unknown coins plus 3. We know that that answer has to be 5, but here's the algebraic version, okay? So I had to do the inverse operation and subtract 3 to both sides, and I get b equals 5. All right, there's going to be an exit card at the end of this lesson with problems really similar to this, so make sure you understand that problem. And if there's time after this and before the exit card, you can go ahead and work on your homework. Let me know if you have any questions.